Nano fam, welcome to the last stream of this year. Nano is the light, as Wenderson says. Yeah, Nano is the light. Welcome, Andefnal, and welcome, Johnny. So yeah, I'm going on vacation over Christmas, so there won't be any streams, and I'm going to resume streaming on January the 9th. So, a little break. So yeah, post your Nano addresses in chat, your names in chat, and then or your Nano addresses if you are a new viewer, and then I can put you on the spinner wheel. So on the spinner wheel, we have Wenderson, Andefnal, Johnny. Oh, Sergio is here too. Hi, Sergio. And Kraptor. So let me put you all on the spinner wheel. Sergio, Kraptor. All right. Yeah, Nano is on fire today, Johnny says. That's right. Did you see the price pump? That was quite a day. That was, let me just open the chart. I still have it. Yeah. Check this out. Check this out, chat. What a price pump that was today. I wonder why. There's so many reasons why this price pump could have happened. Maybe it was Grok. Because of Grok? Because Grok recommended Nano for Twitter. Raindrops, hi there. Are you new? Post your Nano address and I put you on a spinner wheel. Speculation, yeah, it's always speculation, I think, yeah. Or maybe it was the news with the new Fiat on-ramp for Nano? For India and many more countries? Maybe. Or maybe it was something completely different. Who knows? Okay. So for today, let me see what my notes are for today. Yeah. So first, yeah, as always, I say get a Wirex card if you don't have one, and do your daily groceries with Nano. This is not paid promotion. This is just what I do, so that Nano is used more, at least indirectly. It's better than not using it. Okay, Raindrops, I got your Nano address, so let me just copy that and add you to the address book. Address book. Raindrops. And that's your address. And let's also put you on here. Okay. Yeah, so, what else? Yeah, so I wanted to talk about the last stream. Raindrop said it should be paid promotion. Yeah, maybe. But I'm not sponsored. I'm just way too small. My YouTube channel is just way too small. Yeah, so what I wanted to talk about was what happened in the last stream. Because I think this is a really good example of how not to do something. I think I really fucked it up. So in the last stream, at some point, and I think this point was even early, I said, oh, I wished I hadn't done such a huge step, and I wished I had done it in smaller and safe steps. And that was the point where I should have stopped. I should have stopped and I should have thrown the code away and start over. Because that's what I did the next day. So the next day I started where we left off, and I thought I could fix it and I could make it work. And it just got messier and messier, and then I just stopped and I threw all of the code away and I said, I'm going to redo it, and this time in small and safe steps. And that's something that I learned in my career, I would say rather late, throwing code away. It was something that I never did in my early years. And I think we all should throw code away when we notice that it doesn't work out the way we do it. And I should have done it earlier. So if you have not watched the last stream, and maybe you watched the last stream, keep that in mind, that it's a very good example of how not to do things. Yeah, so please chat in the future. If I say, oh, I want to do it in a big step, please stop me. Please tell me not to do it, because sometimes I make this mistake and I take steps that are too big. And it's always better to do it in small steps, I would say. Almost always better. Yeah. And if I left here to rig the wheel, are you? Oh, let's start the timer. I haven't started the Bitcoin block timer. Okay, so the first nano goes out in 10 minutes. 10 minutes, guys. I hope the snow that I added for today is not too much. I think it's a little bit too much. Yeah. Christmas is close, so I thought I would add a bit of snow to the stream. All right. Raindrop says sometimes we need a restart button. Yeah, and we have the restart button. The restart button is git reset hard. Yeah, if we fuck it up, git reset hard and let's redo it. And that's what I did. That's what I did the very next day after the stream. I deleted all of what we did on stream and I started over and I did it in small and safe steps and it went really smoothly. Like no problems at all. No failing tests. I could compile at all times. I could run the tests at all times. That's the way I should have done it. So lesson learned. Don't work in these huge steps. And if you do and you know that and you notice that it doesn't work, throw away the code and restart. Yeah, so let me show you what I did. So if you are new to the stream, let me just show you this simple diagram here. We worked with the wallets class and the wallet class. So wallets, it manages all the wallets of the node. A wallet represents a single wallet. A single wallet can have multiple accounts. And each wallet is stored in its own file, and the wallet store is responsible for that file, for accessing that file. And my goal is still to bring all of that to Rust. So wallet store is in Rust already, so let's make that green. Wallet is now in Rust, so that's what I did this week. It wasn't in Rust last week. And I moved most of the code from wallet into the wallets class because there are so many dependencies that I just wanted to bring all of that code into one place so that I can split it up again, but this time without circular dependencies. So right now, wallets is not in Rust and it has a lot of code in it. And we are going to bring that to Rust. And yeah, and then we are going to decide how to simplify the code, how to split it up. Because wallets does a lot of things, really. And we should extract the different responsibilities into their own classes. And certain things I also want to pull out of the wallets class completely, so that the dependencies are simpler. But yeah, one step after the other. Oh, we have a lot of viewers today. Maybe because it's the last stream. 7 viewers on Twitch. What happened? I never have viewers on Twitch. Hello to all the new Twitch viewers. That's amazing. So we work on the nano cryptocurrency here. And I also give away 1 nano every 10 minutes. So if you want to take part in the giveaway, dear new viewers, you need a nano wallet. You can download that on your phone. Take Nautilus or Natrium, for example, and post your nano address, and you can win 1 nano every 10 minutes. Illy Bob, oh, you're here too. Everything is speculation. I think you're not on the spinner wheel. No, Illy Bob. Andeflar, Gustav, I like how you draw everything in Excalidraw. I started doing the same and it helps me a lot. Yeah, I'm a visual guy. I think about code visually all the time, so I need to draw it. Andeflar says, how did you manage the circular dependency? I did it, so where's the diagram here? So we had the problem of this here. So we had circular dependencies between wallet and wallets. So what I did is I picked all of the code that back-referenced into wallets, and so let's just here. So this little box here represents bit of code in the wallet class that does back references to wallets. So what I did is I took that code and I moved it here. I moved that code into the wallets class, and then the back references were gone. So then there were the references in that direction. So I did that everywhere where a wallet referenced wallets in small steps. And now all the tests go only onto the wallet class. All of the node code goes only to the wallet class. And these two classes are hidden now. So no other places in the node or in the tests have access to them. And now we can just bring them to Rust. And that's what I started doing already. So if we have a look at the wallet class, so this is in wallet HPP. So the wallet class is already completely in Rust. And I started bringing the wallets class, this thing here, to Rust too. And I started with the constructor. So if we have a look at the constructor, okay, we can't see it now, but there was a lot more code here. So this is now the code in the constructor, and it was like twice as long. And if we move to the Rust side, wallets.rs, it's still really ugly. And I don't care about this right now because I never try to do more than one thing at a time. And when I bring code from C++ to Rust, I bring it in all its ugliness to Rust. And when I refactor, I don't want to port. So I either port or I refactor. And right now I just port. So let's bring it to Rust the way it is. And you see all of that code that was in the constructor. All of that code was in the constructor on the C++ side, and it's now on the Rust side. And there's still something missing. So that's why I have this to do here, port more here. And this more thing that we need to port are these lines. Okay, makes sense, I think. Shapeshifter says, hello, hey Shapeshifter. If you want to take part in the giveaway, just post your nano address here. Oh, okay, and we give away the first nano in 2.5 minutes. Yeah, so that's what I thought we could continue today. Just slowly bringing parts from the wallets class to Rust. And then later, so maybe just I give you a bit more context of what I want to do. I want to refactor this a bit later because, for example, the wallet store, I want it to be really dumb. It should be a super dumb class, just loading data from the file and storing data into the wallet file. And currently it does more. It does encryption because the data is stored in an encrypted way. So I would like to move the encryption out of the store and into the wallet class. And the wallets class, for example, it does background search for receivable blocks. So whenever there's a new block that belong to our wallet, it would automatically receive that. I would like to extract that functionality into its own class outside of wallets, because that is a complex thing and it brings in a lot of dependencies. And yeah, I think ideally wallets shouldn't even have access to the ledger, maybe, because also the ledger brings in a lot of stuff. So currently there's the ledger. So the ledger is the database where all of the blocks and accounts and everything is stored. And currently wallets does access the ledger. So maybe we could, I'm not so sure about this, but maybe we can also remove this dependency. Maybe. Shapeshifter says, I'm completely new to your stream. Hey, that's cool. Welcome. What is the reason for you to port that code to another language? So if you want to go into the details of that, you can read about that here on our new website that LFLF has built, RsNano.com. In short, so the original node is in C++, and I want to have it in Rust because of the safety features. Safety features of Rust. And because Rust enables fearless refactoring, and it's just a lot easier for new contributors to work with. And yeah, it's just a lot harder to shoot yourself in the foot with Rust. And also because I'm a huge Rust fan. And I always wanted to help develop Nano, but I never wanted to do it with C++. Okay, so Bitcoin block timer. That is over. Let's give away the first Nano. I hope I have everyone on the wheel. Are you ready, guys? Let's go. Raindrops. Ah, you won your first Nano. Congratulations. So if you have never seen Nano is just really fast. So it confirms instantly. I just put in a Raindrops address, say 1 Nano, I click send, I click confirm, and it's over. Like Raindrops already has the Nano. So it's really fast, very eco-friendly, and super easy to use. Congrats, yeah. Okay. And what does the price do? So because of the pump of today, I just want to have a look at the price. Raindrops, am I that lucky? Yeah, you join the stream and you immediately win the 1 Nano. That's really cool. Underfloss is probably faster than the lag from the stream. I think so. Because the stream lags, I don't know, 10 seconds? Something like that. Okay, and yeah, let's restart. Let's restart the Bitcoin block timer. Yeah, and this transaction with Bitcoin could have cost you like $20. Depends, like Bitcoin fees. They go up and down heavily. 1401, hey, welcome. Next Nano giveaway, 0.7 Nano, next week 0.1. Yeah, I thought about reducing the amount because the price goes up. But it's Christmas, guys. I give away 10 Nanos. 1401, let's put you on the spinner wheel. Because I have your... Oh, I think... Are you in here? Oh, no, you're not. I thought I had have you on the address book. All right. Yeah, so I thought today we could just continue bringing the wallet code to Rust. And once we have all of that in Rust in the next streams in next year, I want to focus on refactoring everything and simplifying everything. And I just saw, so if we wanted to bring this part to Rust, I just saw that it's not easy at all because it calls enter initial password. And if we have a look what enter initial password does, then we see that, so all of these lines are okay, but then it calls enter password, and enter password is a problem because it triggers search receivable. So this is what I just talked about. The wallets class does repeatedly search for, is it repeatedly? Yeah, so it searches for blocks that it can receive. And this is the search receivable. It's a huge function again. Like, oh my god, just way too big. And we can't bring that to Rust easily because, so let's see, so it does transaction, it opens a transaction, so it searches the pending store. So this you see here, node.store.pending. So this is the pending store, and it is a table where all of the unreceived blocks are stored. And so what it does, it goes through all of the unreceived blocks, And what does it do then? Yeah, so this part is a problem. So here it in this code part it creates the receive block. Receive async. So this we have to bring to Rust. Receive async. And this will be maybe hard. I don't know. And this part is definitely a problem. Node.start election. So this starts an election for the new block. But we don't have access to Node. Node is the top level class. This is just a really bad circular dependency here. So I had a look at start election already, and it just calls the manual scheduler. So we could call the manual scheduler to not have the circular dependency, but we don't have the manual scheduler in Rust. So this is still C++ code. So we could go in two ways. So either we stop here and port the manual scheduler to Rust, and I don't want to do that because I want to focus on the wallet's code. Or the second option, which I prefer, is that we don't directly call the scheduler here, but we just add a callback. And then we connect the callback in the C++ code. So that when the Rust code calls the callback on the C++ side, we delegate that to the scheduler. So I think this could be a good start to decouple here. That we don't need access to the node, that we don't need access to the schedulers. And we just call a callback here. Are you with me, chat? What are your thoughts? Please let me know. Or do you have another idea that I haven't even considered yet? Oh, and if Mal said it hurts just to scroll through it. Yeah, just so big. Doesn't even fit. Oh yeah, I have a huge font size but it doesn't fit the screen. It should fit the screen even with this big font size I have. And a lot of indenting. So if you guys are with me, I think I want to start here. I want to decouple this line. I want to add a callback here. And we can do this very simple in here. So let's just say we create a function. And oh, how is the syntax? My C++ is just... I'm not a C++ dev, by the way. So when it comes to writing C++ code, I'm always a bit... I struggle a bit. So this is... Okay, stat function, and then you write it like that. Okay. So stat function, and that function returns void, and it takes a block. And what is block? What is block? A shared pointer. A shared pointer of nano block. So, and start election takes shared pointer reference to nano block. Okay, so this is just a function that takes a shared pointer to a nano block. And we call this start election. And yeah, let's initialize it with... Oh, it needs the node. Let's do it like that. So node... Oh, do you still see this? Yeah. And then it takes the block. And then... Is that, I think it's like that. Is that correct, the syntax? No, it doesn't look correct. Is that function? Start election. 1401, since gambling is fun. Yeah, gambling's, yeah, that's the right that's the right choice, 1401. Let's add you to the spinner wheel. And we still have plenty of time. 1401. And 1. That's your address, yeah. Okay. So please excuse my bad C++. Chat, where is the error? I think there's something wrong here. Do I have to give the types here? Maybe I do. Do I have to give the full type? Node encapsulist does not name. Why can't I capture node? Let's have a look at the error message. Node encapsulist does not name a variable. Oh, can't I capture fields? I have to capture variables. You know what? I'm just going to capture this. Because... why not? We want to move that out of here anyway. So I just want to get a starting point. So this is obviously not a good idea. But I just want to get started somehow. So can I say this dot node dot start election block. Member reference type wallet's pointer is a pointer. This L. Yeah. This looks good. Okay, let's spin the wheel. Fortune1 says, never saw that many people on the wheel. Andeflan says, can't do C++ or Rust, but I agree with you completely. Oh, I already forgot what I said. You agree with what? Croptor, congratulations for 1nano, winning 1nano. Croptor, 1nano. And it is sent instantly and eco-friendly. And let's restart. Okay. So you Twitch people, did you just stumble upon the stream or was that on purpose? So, okay, we have a callback. And now down here, we now call our new callback. So we say start election block. Does this work like that? It does. Okay. So now the next step is we take this callback function and we move it out. Let's just move it to the top for now. So we just want to separate the code a bit more because this, we don't want to bring this to Rust. And maybe... oh. Yeah, let's leave it up here for now. It won't stay here, but I just wanted to move it a bit away from the code that we actually want to bring to Rust. Yeah, so let's add a comment here. Port this, and we don't port the callback function. So we have a decoupling. We have this decoupled now. And the other thing we need to bring to Rust is this call, the receive async. And if we have that in Rust, we can bring all of this code to Rust. So let's just check what this does. What does receive async do? Here it is. It calls into wallet actions. Yeah, so wallet actions is a queue of callbacks. And I have just ported that to Rust. I ported it today. I ported this queue to Rust today, so we can use the wallet actions. And we can call queue wallet action from Rust. What does it do? So this looks really complicated. What does it do? So, oh, it calls something else. It calls receive action. So it's time. It's time for drawing a bit, because this gets complex now. So let's move that to the bottom. Let's move that to the side. So we have. So again, I want to draw boxes. Blue boxes should represent functions. So let's add a box and let's make it blue. And it says search. No, what was it? Search receivable? What was the name where we started? What was the top thing where we started at? So this is the wallets constructor. Yeah, so wallets, let's draw all of that. Wallets constructor called enter initial password. Enter, let's make it smaller. Enter initial password. So the constructor called enter initial password. Enter initial password called enter password. Enter password. Like that. Enter password called search receivable. Search receivable. And search receivable. Now this is getting really, really complex. Search receivable calls receive async. Receive async. Oh. And receive async calls. Receive async calls. Receive action. Oof, what's that? Oh no. I should have rehearsed this. I always end up in trouble because I don't really have a look at what I want to do on stream. Oh, there's so much chat. Andefnau says, still 5 people from Twitch. Let's see how many will be watching at 11 o'clock. Insane work, says Illibob. What a legend. Oh, thanks, Illibob. 1401. Are there any large language models that can draw flowcharts, diagrams from code? That's a good question. I don't know. Are there? That would be insanely helpful for what I do. They should be capable, shouldn't they? Because they can read code. 1401 says, no, Andefnau says, I think it helps you understand the code better when you draw it by hand. Yeah, it does, but for a very quick look, if I could just say, oh, draw me a flow diagram here. 1401 says, good point. Oh, it's 8 people from Twitch. Cool. I was wondering if that might be helpful in visualizing, explaining the node software. We had this discussion recently about a lot of nano code not being well documented. It would be helpful. It would be immensely helpful for me, and I think for others too. Because like what I do now, manually drawing those things, it also takes time. And if that could be done quickly, would be cool. But now this is maybe a dumb question, can ChatGPT draw stuff? I thought it was just generating text. Can ChatGPT draw diagrams? 1401 says, I mean, ChatGPT and others can decently annotate and explain code quite well. Yeah, I've seen that. With code annotations as comments. But as diagrams, that would be cool. Okay, so receive action. What a monster. Receive action. My plan for today's stream is just exploded. I thought we could just bring code in small steps again, but to Rust. But this looks bad. What does receive action do? Yeah. Okay, receive action is not bad. Oh, what is that? Action complete? All of that code up here is not a problem. Action complete is a problem. So what is action complete? Let me just add the action complete. Action complete. And I'm not sure why the wallets class uses this callback queue. Not quite sure why it does that. We will find out. Action complete. So are we... No, we are not at the end yet. So this calls delayed work. What is delayed work? An unordered map. Okay, so we have to bring delayed work to Rust first. So this... We have to bring delayed work to Rust. And we have to... work ensure. And what is that? Work generate blocking. That's not in... Oh. Maybe this is too difficult for today's stream. Let's see what this work ensure do. Delayed work. Again, that is that, yeah. Workers at time task. Okay. So maybe... Yeah, let's maybe do a giveaway. Undefnal, should we stop you? Yeah, I haven't even started. Elibob, 1 nano for you. I haven't even started. Okay, I have a plan B. So as you have seen, this is really difficult. So the plan B is something we could continue our work at that place that brought us to the wallets class initially. And that was the function for each representative. This here. And this iterates. Yeah. This iterates all the representatives of this node. And it calls an action, a callback for that. And the reason why we need this in Rust is... Yeah, I think we... Chat, are you okay with that? Because we could continue... we could continue here on this thing, but I promise you it will be difficult. And maybe it is better to work on something that's not so difficult, at least on when I'm on stream. Yeah, so this function for each representative, let me just make sure that this is now actually fine, that we don't have any more dependencies that we need to port. But I think this looks good. We have wallet, we have store, we have ledger. We have all of that. Yeah, this is okay. So I think we should bring this to Rust. And we need the for each representative function in, where was it? Voting? Yes, I remember. We need it here in the vote generator. So if you remember a couple of weeks ago, I said I wanted to bring the full vote generator to Rust. And I have maybe like 80% of the vote generator code in Rust already. But this function here, vote, which creates a vote, it calls wallets.forEach representative. And that was the point where I decided to work on the wallets class, because we need it here. We need to call wallets.forEach representative. And back then, I couldn't bring the forEach representative method to Rust because it had these circular dependencies. And now we don't have them. I fixed all of them. So we can now bring this to Rust, and then we can just finish the vote generator. So let's do that. Let's do that. 42 minutes of streaming already, and we haven't even written a single line of code. Sorry, guys. Sorry, guys. Zoltan says, go nano. Yeah, go nano, Zoltan. Send your nano address and you can win 1 nano. In 6 minutes is the next giveaway. Yeah, so let's do that. Let's bring the for each representative function to Rust. So for that, I'm just copying the whole function. And then I'm moving to... No, before I do that, let's just say what it takes. It as arguments. It takes a function that takes a public key and a raw key. Okay. Yeah, so let's start with the foreign function interface, the interface between C++ and Rust. And for that, let's go to the file wallets.rs in the folder FFI. So here is the glue code between C++ and Rust. And let's add a new function here. And at the bottom. Oh, is it visible here on stream? Yeah. So let's add a new, or can I say like this? Yeah. So let's add a new function here. External C, so this is C calling convention that we can call it from C++. RsN wallet. No, not wallet. Wallets. For each representative, and it has to take the handle which points to our wallets instance, LMDB wallets handle, and it has to take, so this is the C++ part, it has to take this here, function, public key, private key. So this is again tricky, but I've done this a couple of times already, so I know how to bring that callback to Rust. So for that callback, how's it called here? Action. So let's do the same in Rust. Let's call it action. Action is a function, is a callback, and how do we name this? for each representative action. And this is an extern C. So also C calling convention function. And so if you see this for the first time, maybe this is a bit confusing, but it will soon make sense. So this will take a void pointer. And this void pointer will be a pointer to the actual C++ callback that we want to call. But we can't call it from Rust because, of course, we are in Rust. We can't call the callback pointer here. So this is why it is just a void pointer, so that we don't know the type. And the flaw says, but we draw a lot. We draw a lot. At least we do something. Well, you draw, we don't. Yeah. So this takes a void pointer. So this is the pointer to the actual callback in C++ that we want to call. And then it has to take the arguments. And the arguments, as you can see here on the C++ side, for the callback are a public key and a private key. So to pass the public key and the private key from Rust to C++, we just use byte pointers. Like that. So 2 byte pointers, one for the public key and one for the private key. And this is our callback that we take in our for each representative function. So this is a for each representative action. Makes sense? I hope it makes sense. Sorry that this stream is again a bit complex. But yeah, bringing Nano to Rust is not easy. And all of the easy stuff is done already. So what's left is a bit hard. It will become easier once we have everything in Rust. By the way, is the block timer running? Yeah, it is. Okay. So here we say handle. So this is the handle for our Rust instance of the wallets class. Here we want to say for each representative. And this function doesn't exist yet. So let's create it. Can we create it, auto-create it? No, we can't. So let's go to wallets.rs, the other wallets.rs for the implementation in the node folder. And let's add, oh, I already have it here. I started that weeks ago, and then I noticed that I can't continue here. Oh, isn't that great, chat? We have something already. We have something already. So let's just remove that. I want to start fresh. Let's just keep the to-do. So as you can see, we have that already. For each representative takes action. And action is a function that takes an account and a private key. Account and public key, by the way, is the same if you're wondering. Wonderful early Christmas present. So time for the spinner wheel. Let's go. Sergio, congratulations. Sergio, 1 nano for you. Sent instantly and fearlessly and eco-friendly. Yeah, that's cool. So we have that function. So let's call it. Let's call this function. And so it takes the account and the private key. These are the two arguments. And what we want to do now is we want to forward those two arguments to C++, so that the C++ part can call the actual callback. And we can do this by... Yeah, there's something missing here. Because we get our callback here, but we need this pointer to the actual C++ callback. So this here, what's a void pointer here, we need that. So we have to pass it in. So I'm calling this action context, and this will be a void pointer. And because this is heap allocated, and when we are done with everything here, we have to delete. To free the memory, we also have to pass in a callback for calling the delete. sorry, chat. This is complex. I have not found a simpler way. So we need to pass in a callback, and I call this delete context. And this is void pointer callback. So let me show you how this looks. So this is just a function that takes a void pointer. And we use this to delete our this void pointer when everything is done. So and I automated this calling of the delete function in a helper struct, and that helper struct is called context wrapper. So let's use that here. So let context wrapper equal to context wrapper new. So this takes the action context, and it takes the delete context function. So this will call the delete when it is destroyed. And then let's move the context wrapper into our callback here. And now we can say, let ctx is short for context here, context wrapper dot get context, and this returns the void pointer. I have to say sorry, chat, again. Sorry, I did not think that it would be that we would end up in a complex thing again so quickly. So this returns. Are you still following? I think this we can just won't go on forever. So maybe just 20 minutes, and then we can go on with simpler stuff. So here we have our context, and now we can call the action with... Why does it make action? Okay, green. Raindrop says I am. Oh, that's good. At least one of you is following my messy stuff that I do here. But I think there's just no simpler way. Or if you know one, let me know. So here, action takes as a first argument the void pointer, so the context, and then it takes the bytes of the public key and the bytes of the private key. So that we can do with count dot as bytes. What does this return? You ate a byte array of 32 bytes. As pointer. And the private key is private key as bytes as pointer. Like that. I think that's it. 41 says there's always the point in time on any dev talk when we start pointing pointers and pointers. Yeah, you are right. You are right. Software development is complex. Yeah, 41, but that's the point. Yeah. Pointers for pointers for pointers, pointers to pointers. Okay, that's it. So let me just talk through this again, because it is complicated, but this is the pattern that I have used a couple of times already, and it works well. So our for each representative FFI function, it takes this C function pointer, which takes just a void pointer, which is the actual, which contains the actual C++ callback that we want to call, but we don't call it from here, we call it on the C++ side, and that's why we pass it in here. And yeah, and it takes the bytes of the private key and the public key. And what we do here is just a pointer conversion. And now you can just forget about it, because, yeah. Just forget about it, because now it gets simpler. Let's move back to the C++ code and let's implement the glue parts that we need here. So here we want to call our new function. We want to say RsNano, RSN wallets for each representative. And the first argument is the handle. The second is the action. So here we have to do something. So let's do that. So we have to create a callback. We have to create a callback, and how do we name that? For each representative action. And this now takes a void pointer, context, and it takes the byte pointer for the public pub key, and it takes a byte pointer for the private key. And yeah, here we have to do something. But let's skip that and let's just finish the code down here. Crapter says, have you had any exciting software development jobs? Exciting. Yeah. Well, I find, well, that always depends on the person. I find a lot of things exciting that maybe others don't. So, for example, for the last 10 years, I implemented a point of sale system from scratch, like a greenfield project for a company that produces point of sale hardware. And I had the opportunity to develop the whole system with the back office and everything. And that was exciting, because point of sale systems, they can be really complex too. And they were all connected or via the internet, and you could have like live view into all of the sales and stuff like that. So that was really cool. What about you, Chat? Like, what were your most exciting projects? And Nano is my most exciting project. So I've never worked on something that excited me more than Nano. That's what's the reason why I started this RsNano project. Because I love Nano. I'm just a huge fan, and I always wanted to help, but I didn't want to work with C++. That's why I started porting it to Rust one day. Just one weekend, I don't remember the exact day. Just one day I just thought, let's just write a little bit, just a couple of lines, and let's see if I can bring it to Rust. $14.01. Congratulations. So your gambling addiction starts here. 14.01. Oh, Nano. And what does the price do? Yeah, stable. So here we call into the Rust part, and here we have to give the context. We don't have the context yet. Let's create that. And here we have to give a function that deletes the context. We don't have that either. Delete for each representative context. Yeah, let's start with the delete function. Delete, does it? Oh no, let's just copy it. The name is just too long. This just takes the context, which is a void pointer. Okay. And here we have to delete the context. So what is the context, you might think? So as I said earlier, the context is a pointer. And we use the new keyword here. And you should not use new when you work with C++. But in this case, we have to. We can't use auto pointers here. Is a new std function. Now let's just copy that too. So this function is the callback. This here is the actual callback. And we copy this into, we do a heap allocation here, and so that we have a pointer that, or a memory address that does not get deleted. And we just move the callback into that heap allocated area with this line. And that is the context. And we have to delete that context up here in the our delete function. So we have to just do a cast here where we cast the void pointer back into our function pointer. Like that. So this also looks complicated. We are almost done, chat. I promise it won't be long. So here we can just call delete action. So this will delete our callback. And up here in the for each representative action, we do the same. We cast the context back into the actual callback, into the function, and then we call it. Call it with, oh, now we need the pub key, so nano public key. So this is the real public key. I need a different name, so maybe let's not name this public key, but let's call this public key pointer or bytes. Private key bytes. And then can we copy them? Pub key is there? Yeah, copy, no. From bytes. That's cool. So the pub key bytes. Oh, this is the static. Oh, it's a static function. We can't do it like that. So we say nano public key, pub key. So let's say auto pub key, and then we say nano public key from bytes. Let's move that in here. Let's do the same for the private key. Is nano private key? No. Raw key. Sorry, raw key is the private key. Does it have the same? There is no from bytes, but I want to add that because this is just a function that I need all of the time. So let's just do a quick detour and let's add that. And then we can call the callback, and the callback now can take the pub key and the private key. So chat, that's it. I promised you it won't last forever. Oh, and Undefnal says, by the way, Gustav, ChatGPT has no issues with creating a planned UML representation from the Nano wallets for each representative. It looks cool. Oh, can you send it? I want to have a look at it. LFLF, why should you not use new in CPP? Because CPP has the way better auto pointers, like shared pointer, unique pointer, and those pointers they automatically free the memory when they go out of scope, and you can't forget to call delete. If you use the new keyword, you have to remember to free the memory. So you have to call the delete, and that's just so easy to forget, because let's say you also have to do this in case of when an exception occurs, for example. And so there's just a lot of ways where you can forget to call the delete. So that's why you shouldn't do it. You should use the auto pointers. You should use unique pointer, shared pointer, and whatever else there is. But we can't here, because we actually don't want this pointer to be deleted by C++. Okay, so that's it. We got all of the clue code here. I understand, thanks, yeah. So yeah, that was the old way back then when the auto pointers. So I'm old, guys. I'm old. I was a C++ dev in the years in the late 1900s. I was a C++ dev in the late 1900s, and back then there were no auto pointers, and you had to use new and delete, and yeah, it's just horrible. And C++ was completely different back then. Like, C++ now looks like a completely new language. It has changed so much. This has nothing to do with the C++ I worked with back then. Undefnal says, I don't know if you want the screenshot or the too long plant UML. Let's click that. Let's just click the link. And let's go here. Cool. Nano wallets account function. Okay, transaction mutex node. Yeah, so the problem, so you took the C++ code base here, and this doesn't look too bad, really. But if we really have a look here, oh, can't we soon? Can't I? Oh. The problem is this box, Nano node. So wallets has a dependency to Nano node, and Nano node is actually the node. The whole software that we write here. So node is like the main entry point. So wallets has a dependency to node, and node has a dependency to everything else, to absolutely everything. So wallets uses the node to access whatever. So that's why this diagram doesn't look bad, but in reality it's really, really bad. So wallets actually has a lot more dependencies than you can see here, because it accesses those dependencies via the node field. Cropter says Nano is still undervalued at $1. I agree. I think it's massively undervalued at $1. But that's not a financial advice, guys. I don't know if you want to... I've written that. I read that already. So one more Nano to give away. Sergio, congratulations. Dropter says, why didn't they just code Nano without dependencies in the beginning? What do you mean without dependencies? I mean, we always have dependencies and we have to manage them. I can see why they did it, because it's just very easy because if you do it like that, if you design it like that, you can just access everything via the node, and then you just don't need to think about how to manage dependencies, because you can just access anything here, and it makes, yeah, you don't need to think about that. And I think that was the reason, because it was just easy to do. But what it does is you end up in a huge spaghetti mess. If you never think about how dependencies should be, and everything can depend on everything else, you just end up with this huge blob of code that you can't separate anymore, that you can't understand in small chunks anymore, that you can't test in isolated chunks anymore. So please never do that. Never do that. It's a good thing to think about dependencies. 14.1 says, but this might be a nice way to analyze a structure within the code. ChatGPT planned UML code graph. Yeah, I'm happy, really happy about that suggestion here. I'm going to do that from now on, because this will speed me up. Speed up my work here. If I can just let ChatGPT create those diagrams. Great idea, Chat. Thank you very much. Really cool idea. Crafter says, I heard rumors that they were gonna remove all dependencies. What? Which dependencies? Who's gonna remove dependencies? And which ones? So you always have dependencies. If you don't have dependencies, then you maybe just have one mega function, just one really huge function where everything is in that function, and then you don't have dependencies. So dependencies are not bad. So dependencies are not the problem really, but the wrong dependencies are a problem. And if not, says, if you don't have dependencies, you're dead. Yeah. That also solves the problem, yeah, if you're dead. So private key, so what, yeah, so let me just, so the from bytes, let me just copy, I'm just copying that, because this will be a helper function that I need in the future too. So let's just go to raw key. Oh, why can't I jump to raw key? I can't jump to raw key? Where is it? Here it is. Oops. So this should also have nano raw key is the result. Sorry, raw key is the result. And this must be static, yeah? Like that. So let's copy and paste that function here too. So this is now a raw key. And this takes raw key and copies 32 bytes. That's correct. And returns... No, it has to return a raw key. Yeah. And now we can use it here. And what's down here? There's still a handle. What's the error here? Oh, so many errors here. What? Did I mess up the parenthesis? Action. Expected for function, style cast, or type construction. Yeah, I think what did I do wrong here? Yeah, there's a second one missing, maybe. No, the pointer has to go here. Yeah, so that was wrong. Okay. So So now we just have the problem here. Use of undeclared identifier handle. Why don't we have a handle? We are in the wallets class. There should be a handle. Where's the handle? Oh, it's called Rust handle. Okay, Rust handle. And too few arguments? We're missing an argument. Which argument is missing? So what does it take? It takes handle, action, action context, and delete. So we have handle, oh, the action is missing. So what was the action for each representative action? So I want to add some line breaks here because this is it's getting too long. So for each representative action, then the context, and then the delete. And no more errors. We got it, chat. We got it finally. So I'm really sorry that... Oh, timer! Sorry, guys. Thanks, Craptor. I forgot. Sorry, guys. But don't worry, we are going to give away all the nanos. So how late is it? Oh, time flies. Okay, we got that. We got the callback. We got all of the glue code. And now we can port this code. So the thing we originally wanted to do, we can port it to Rust. So now we can go to our Rust wallets implementation, into our for each representative function, and now I'm just pasting the C++ code here, and then I'm just going to uncomment all of that. Okay, so now we have the C++ code in here, and it's uncommented. And now we can just port it line by line. Crafter says, Grok AI is smart. Prompt, does your daddy know what's the best currency for the world? Well, my daddy Elon Musk has mentioned that the best currency for the world would be one that has the least error and latency. Yeah, Elon actually tweeted that. In other words, a currency with a strong information theory foundation. Yeah, but it didn't recommend Nano yet. It did. It seems that Nano XNO is a strong contender for this title, as it has been mentioned by several sources as an ideal cryptocurrency for payments on X. Wow. That's just really cool. So maybe Elon will finally stumble upon Nano. Who knows? That would be amazing. Because it actually would be the best currency. So, timer running, yeah. 5 people on Twitch. Great. 5 people on Twitch. Never had so many viewers on Twitch. Okay, so now it gets easier, chat. So we have the hard part behind us. So now we can just one by one line uncommented one by one. So let's just uncomment this if up here, and also the matching closing brace, and it says if node voting enabled. So here we can just say if self dot we don't have the config. We don't have the config. here. Or I think we just have not assigned the config to the field. So this is also something that I see a lot in the Nano code, which I want to change. So there's this node config struct, and this is it. Look at that. So many things. And all of the classes are just using the node config directly. And then they just use one field of it. And all of the other fields, they don't use. So I'm not a fan of that at all because of coupling again. So we have so many unrelated fields here. And we maybe use just one, maybe just two. And we don't use the other fields. And still we have to provide this huge monster of a config struct to our class. And I don't like that at all. So I would prefer if we would just pass the one or two fields that we need into our class. And then this would be simpler to use, because all of the places that use our class, they would not have to create this huge node config thing, but they could just create a very small and simple config class. Or maybe even not a class, maybe just pass an int or a bool or whatever. But yeah, let's keep that for now. I don't want to mix up different types of fork. I just want to port it first, and then I want to refactor it and want to remove the node config. So let's add a field here. Node config. And I'm just going to copy the whole config because I know I'm going to refactor that away anyways. So cloning here is not a problem, really. So let's add that here. So node config is node config.clone. So that clone, it doesn't bother me because... Oh, it doesn't implement clone? Node config doesn't implement clone? Why not? I'm just going to make it clonable. Derive clone. Why not? Okay, optimistic scheduler config is not clone, so let's make that clone. So making those clone is not wrong. And hinted scheduler let's make that clone. Oh, there's still something wrong. Consider annotating. Oh, okay, it was just slow. The trade bound is not certified. There's something that still isn't clone. Oh, so many things that are not clone. But I'm going to make all of them clone. I don't care. These are just data structures. They can be clonable. That's not problematic. Derive clone. WebSocket config. IPC config. Diagnostics config. See, that node config is a huge thing. It has so many dependencies. And we bring all of those dependencies into our wallets class just by using it. Oh, did I miss any chat messages? Crupter says, hopefully he does not fork it and claim he created it. Oh, yeah. Grog asked you, does your daddy know what's the best currency for the world? No. Okay. So, what else has to be cloned? Stats config has to... Oh, let's make all of them clone. Load cache config. Okay, stats config. There's still something wrong here. Oh, I did a typo. Made a typo. Derive clone. Okay, finally clonable. So let's go back to our wallets struct, and here we just clone the config. And then we can use that config here in the if clause. So if self.nodeconfig enable voting. So here we are, chat. First line that we ported to Rust. at least one. After 1.5 hours. So next line. What does the next line do? Accounts, action accounts. So this is a vector. So let's also create let action accounts L. So this is a vector. Just a new vector. Let's maybe define what it is. So this is a vec of pairs. And of pairs of public key and raw key. And it has to be mutable, I think, because we're going to put stuff into this vector. But first, nano giveaway. And is it? Raindrops. Raindrops, another nano for you. Congratulations. Bitcoin block timer is running. We have 3 more nanos to give away. And we have half an hour left. And if now it will accelerate one line after another. Yeah, let's hope. Let's hope that it will accelerate. So we have the vector. And then what do we have here? This starts a new scope. And where does it end? Here. Wenderson says, ich bin hier, gute Nacht. What language is that? Nano is the light. Nano is the light, Wenderson. Nano is the light. Have a good night. So now we auto transaction. Okay, so now we create a transaction. So let transaction L and self dot environment. So this is the LMDB environment. What a retransaction? Yeah, retransaction. So that we have ported this line. See, chat, now it's easier. We have the hard part behind us. So here we create a transaction. Now we lock the mutex. Mutex lock. So next line, ported. Looks like Dutch, yeah. It's almost German. Yeah, the Dutch people, they are so good at understanding German, and the Germans are so bad at understanding Dutch. All of the Dutch people I've met in my life, they all could speak German. So wallets lock get also. Now we iterate the wallets, and the wallets, they are protected by this mutex. So now we can say for, yeah, let's keep the variable names, even if they are not good. For I in lock dot. Do we just need the wallets, or do we need the wallet ID too? Because this mutex is a hash map wallet ID wallet. Yeah, we just need the wallet. So we can say for wallet in lock.values. And this will iterate all the wallets. So we don't need that. We don't need that. Just need this brace. And this brace at the bottom. And we don't need that line. Okay. Next line is unordered set representatives L. So let's also do that. Let's create representatives L. And let's say this is a hash set. A new hash set of accounts. Oh no, oh here it is. We assign it here. Wallet.getRepresentatives. Yeah, then we can just call it directly. Self.get. There is no get representatives. I just want to have a quick look what get representatives does on the C++ side. Okay, so this also has a mutex that has to be locked. Okay, so wallet dot. Yeah, so it has the representatives mutex here. Mutex hash set account. Yeah, I'm really not a big fan of accessing mutex fields of other structs. I think this tells us that the boundaries are not defined well, but let's just make it work first and then we refactor. So let's lock this mutex, and I think this clones. It clones the representatives. And that means we have those lines ported. Yeah, we're getting things done, chat. We're getting things done. I think we will have the whole function ported soon. What's new in chat? Wenderson says, no, I just live here. So you live in Holland. Nano is the light always. Yeah, Nano is the light always. I'm sorry I lost my life, my friend Gustav. I don't know what you mean by that. So, 6 viewers from Twitch. What's happening today? Something happened on Twitch. Okay. So next line is the representatives. So now we iterate the representatives. So here, so we just say for count in representatives. So that's that line, and now that brace. I'm commenting that brace. Next line is if wallet store exists. So here we can also say if wallet store. Oh, this we can just port that exactly as it was on the C++ part. It takes the transaction. And it takes the account reference. Yeah. See, chat, this is now easy stuff. Finally easy work. LF, oh, so you want to move to the Netherlands? Cool. It's a nice country. I've been there a couple of times. So So next one, if. So self ledger. Wait to 0. If expression is missing, what is it missing? What's wrong here? A field with the similar name. Oh, we don't have ledger. Yeah, we can fix that quickly. So I think, yeah, we get the ledger in the constructor. We just haven't added a field. So let's do that. Ledger is arc ledger. And let's initialize that field here. Arc clone ledger. Oh, the music has stopped. Let's just rewind it from the beginning. Like that. So now consider borrowing here. So account, yeah, we have to borrow. So next one, if wallet store valid password. So let's uncomment that. So if wallet.store.valid password. Then we go in here, else we go there. And what are the next lines? Wallet store fetch. So here we call wallet store fetch. And how does our fetch look? Yeah, time for a giveaway. Short break. Wayne and I really enjoy life there. Here, people are really nice. Yeah, I can confirm that. And if null, hey, your first nano today. And if null, 1 nano. There you go. 2 nanos left. And timer's running. Okay. 1401 says, just checked. There are exactly 4 dev streams with the Rust tag on Twitch at the moment. Whopping 16 combined viewers. Yeah, maybe it was the Rust tag. Maybe it was the Rust tag. Or maybe sometimes you just have to be about, because you start streaming and at the bottom of the page and it's ordered by viewers, so maybe you just need that amount of viewers to be discoverable, so that critical amount of viewers so that more viewers can find you. I don't know. Okay, so fetch takes transaction. And what is the account? And it returns the private key. So let private key equal that. And is that... Oh, it's a result. Result raw key error. So how is the error handling here? There's no error handling here. Just a debug assert. I think... Oh, how are we going to handle that here? How are we going to translate that? There's no real error handling on the C++ code, but we are forced to implement error handling with Rust. Yeah, that's why I like Rust so much. It forces you to handle errors, or at least to be very explicit that you ignore errors. Should we ignore errors here? Or can we... Should we panic? LF, oh, what are you saying? I'm learning Dutch currently. It can be a Dutch nano meetup with at least 2 people. Or if if there are people near Stuttgart, we can do organize a nano meetup here. I live in Stuttgart. Frenderson says you're doing a great job. Oh, thanks. So private key, yeah. So how are we going to handle errors here? So what if the wallet store cannot fetch this account? What possible errors can there be? Okay, the password, so the wallet could be locked. Public key was not found. Okay, so there's a couple of things that can go wrong here. But it shouldn't really, because yeah, here we are validating the password here. I think I just want to panic. Let's panic here. And with the error message that says could not fetch. Yeah, what could not fetch? Account. From wallet? No, don't know. So yeah, let's panic here. And then the last line is... Okay, so here we are pushing that private key into our vec. Push. And it's a tuple of account and private key. So that is done. And the next one is just these lines. Static order last log. Static. Oh, it uses statics. Global variables? That's not good. That makes testing impossible or really difficult. I don't want to use a static here. Last log. So this is just that it doesn't log too much. So if the last log is bigger than 60 seconds, only then it writes this log message here. And I don't want to use statics here. That is not a good thing. Because I want to write unit tests for this later. And I can't do that with statics. What to do? So at most once per 60 seconds it writes this log message if the wallet is locked. Representative, what is the message? Representative locked inside wallet, and then it says the wallet ID. Oh, here's the wallet ID. So we need the wallet ID. But why does this have to be static? I think there's only one instance of the wallets class. I think we can just make it a field. We just have one instance of the wallets class. So let's make the last log a field. Yeah. Let's make the last log a field here. Last log is instant. And oh, now we have to initialize the last log. Or should it be an option instant? Could also be an option instant. Yeah, let's make it an option instant because we can't initialize instant with yeah, with a value that is minimum like yeah, let's make it an option instant. And then down here, we say last log. So we say if self last log elapsed. Okay, so it's an option. So we have to say unwrap or no. How can we do that? Yeah, let's do this in 2 steps. Let's first say, let's first assign a bool here. Should log is so match self dot last log. So if last log is none, we have to log because it's our very first log message. And if it has a value, this is an instant, then we say if the elapsed time is bigger than 60 seconds. Then we should also log. So then we can say down here, so if should log, then we assign the last log again. Yeah, so we say self.last log is instant now. Is some instant now. Yeah, it's an option. And then we can just write the log message. So self.logger, always log. Yeah, giveaway time. (1401). Congratulations. One more nano for you. So representative logged inside wallet. And here we have to give the wallet ID. The wallet ID. We have to get the wallet ID, so that means our loop here, we can't just loop the values because we have to have the wallet ID, so we just say iter, and then we get the wallet ID and the wallet. Yeah. So then we can add the wallet ID down there. Does wallet ID implement display? I think so. Okay. And the last 3 lines. What does these 3 lines call the callback. So that is for representative in action accounts. So now we call. Okay, so this is what is action accounts again? Back public key, raw key. So this is pub key, private key, pub key, private key. And we are done, chat. Oh no, we're not. There's an error. What is the error? Error here. Cannot find function action A. Oh, I think I just called it action. Oh yeah, and there's still the underscore. Let's remove the underscore. Consider borrowing here. Okay, let's borrow here. Yeah. For each representative chat, we ported that function to Rust. And now let's compile everything. Let's run the tests. And let's delete, or have we deleted the C++ code? No, we haven't. So here we call the Rust code. Now let's, thanks Sandivnal. Now let's delete the C++ implementation. So now this is the C++ side of, for each representative, just calling the FFI function. And yeah, so now let's reformat the code. And let's build. All tests. Yeah, let's build everything and let's run the tests. And let's see if... Oh, clone is not implemented. Did not... maybe I haven't saved everything. Where was the error? Where's the clone not implemented? TXN tracking config. In the file diagnostics config rs. Diagnostics config rs. Oh yeah. I thought I was done with all of the derived clones. Let's compile again. No, there's still something wrong. Okay, let's go into the Rust folder and let's run cargo watch. Check. IPC config. Okay. Derived clone. Oh. Okay. This one has to be clone. This one has to be clone. And bootstrap config. Okay, this one has to be clone. Wallets RS has an error. Okay. Cannot assign to which is behind. Oh. Oh yeah, so this is self is not mutable. Self is not mutable. Yeah, so just so that we can end the stream, I'm making it mutable. I'm sure I have to change that back into immutable later, but I just want to get this to compile. So let's make the FFI handle also mutable. Wallet RS. Cannot borrow mutable assets behind a... Oh. Which one did I just make mutable? No, this one. For each representative. What is that? Why are there two functions like that? Rs and LMD wallets for each representative? There are two FFI functions for the same function? Yeah. Representative. This is what we wrote today, right? LMDB wallets? No. 119? We have two functions that do the same thing. Did I implement this already in the past? think I implemented it in the past already. Yeah, let's delete the thing that I did in the past. And let's only use the thing that we wrote today. I had a chat. We could have we could have had an easy life today, and we could have skipped all of that complicated callback stuff because it was there already. Oh man. Crafter says, how many percent of C++ to Rust was that? Oh, I don't know, 0.01. That was really, that's not much really. That reported today. It was, and the file says 0.1%. No, it was even less than 0.1%. Didn't something similar happen last stream too? Yeah, I think so. Okay, so, but now, let's try to compile it again. Okay, looking better. And while this compiles, let's give away the last nano. Because compilation takes a while. So let's spin the wheel one last time for today. For this year, so this is the last spin of the year. Crafter says, at least Nano is breaking out a little bit. Oh, it's at €1.10. It is. Sergio, one more time. You are really lucky today. So you get the last nano. Yeah, look at that. Breaking out a bit. Okay, so chat, this is it for today's stream. So is there anything you want to ask or anything else you want to talk about? Because I'm just letting that one compile here, and then I want to run the tests and see if everything is still green. And if it is, I'm going to push it to GitHub. So to all the new viewers here, especially from Twitch, because I think the guys from Twitch are new viewers. If you're interested in this project, RsNano.com is the website, and LFLF here made it. I really like it. So here you can even see the progress, but the progress is, so December is not in here. What is that? November, 40.77%. Let's see how many percent we have. Let's, oh, wrong. Let's run the script. How many percent are in Rust now? I don't think it changed much because I mainly refactored the C++ code. 41.1 is the current number. 41.1. So here you can find also the links to our Discord, to Twitter, and to GitHub. So here's our GitHub where you can have a look at the Rust code if you're interested in this. And yeah, 17 commits behind, so I have to merge some C++ commits to be par with upstream again. Yeah, so that's it for today. LFLF, why didn't you add me to the wheel? But you are not on the wheel. No. Oh, please don't tell me I forgot forgot to add you on the wheel. No, did I? Oh, sorry. I'm so sorry, LFLF. I thought I had everyone on the wheel. Oh, man. Okay, next stream you get an extra nano. So sorry. Oh. Ryan Drops asks, does anyone have any idea about how many people are using Nano GPT? I don't know. I'm using it from time to time. Do you expect it to go faster or slower in the future? Asked Raptor. I expect it to go slower because in the beginning, the things I could port were easy. And now I'm stuck with refactoring the really difficult parts. And I have to refactor them in C++, and that takes a lot of time. And then I have to bring them to Rust, and then I have to refactor them again. And yeah, so I expect this to be slower in the future. That's bad news. But the good news is that number here, 41%, is really pessimistic because it includes a lot of stuff that I don't have to port to Rust. And it includes all of the glue code that I don't have to port to Rust. So, and it includes all of the tests that are still in C++, and I have to port them to Rust, yeah. But the node will be fully Rust much earlier. So the tests are the last thing I can port, because most of the tests are using the node class. And the node class is the main class. So I have to wait with porting the tests until everything is ported. And so I think we are a lot over 50%, really. And my plan is to have a full Rust node next year. LF was not on the wheel. So this time the wheel was rigged. For LF, you were not on the wheel. Yeah, it was rigged. Crypto, dangerous promise, next stream nano is $100. Oh, yeah, that could be. LF, you should demand 2 spots on the wheel this one. Yeah, oh, that's also a good idea. Maybe I give you 2 spots next stream. Yeah, there won't be any more streams this year. So the next stream is going to be on January the 9th. So when the same day when we have our public Twitter spaces, dev spaces again. Okay, compilation takes forever. I thought maybe we could just have a look at the tests before I stop the stream. LF says, no problem, just noticed I don't need 2 spots. Yeah, but I feel sorry. Because you were there, you said that you're there, and then I forgot to put you on the wheel. Okay. LFS progress on websites is updated, by the way. Oh, did you? Did you? That's cool. That Docker bug was wild on Nanospaces today. Yeah, because I had a private chat with Gravity, and we tried to figure out where these strange pauses came from, and they came from Docker. Yeah, it happens from time to time. Sometimes we are just focused on a problem that isn't a problem, really. That pause, yeah. But that's good news. When he told me that there is no problem, really, that's good news. That's what I want to hear. Yeah, so is the thing updated? Let me see. Reload. Oh, that's cool. So quick. Yeah, as you can see here in this graph, the progress has slowed down. It's not as fast as it was here in the beginning, but that's not so bad. So I think we will have a full Rust node in. Now this is just a guess. Now don't take my word for it, but I think in 6 months. So mid next year, full Rust node. Okay, 5 years. No, much faster. Next year. I think definitely next year. Because we have... Check this out, chat. Let me show you. So, while this still builds... Oh. Let's go to node.cpp. HPP. Node.hpp. This is the main class. So this is the full node. And I added comments here, what I ported already. And as you can see, ported, I ported almost everything. There's just a couple of things missing here, and some of them are small. So wallets, of course, I've been working on wallets. Yeah, the WebSocket server. Yeah, so the block broadcast. Is this ported already? No, so these are just some smaller helper functions, classes, that I still have to port. Here, they're really small, so they should be quick. And then we're done. But you have to multiply the estimate by 3. Yeah, I actually multiplied it, not by 3, but... yeah, but... I think, okay, so that, yeah, we should always give a range. So I think it will be, we have a full Rust node between mid next year and end next year. Yeah, that's better. That's a range. Standard, yeah. Still building, still building. Okay, chat. I think I want to end it because it's still building it and running the test. It takes also some time, and that's just boring. I hope you had fun. I hope you learned something, or I hope you won nanos. And I wish you a Merry Christmas and a Happy New Year. And we see each other again in January. So enjoy the vacations, the holiday time. And yeah, see you then next year. Bye, Nano fam. Nano is the light. And let's hope that next year the price hits $100. Okay, guys, bye.